is Mrs. John, and this is lesson 4 for year 13 physics, and this lesson was solving problems on center of mass. I've kind of copied the question over here so you can see what the question is, and here is the solution for that. If you'd like to take a look, work through it first. And this one, the question's at the bottom here, and the line that you see going through is, so you've got Jane and Tana, astronauts who are kind of going, they're connected by a cable of length 6.5 meters. So this whole thing is 6.5 meters, and you've got to calculate the distance of the center of mass of the system from Jane. So you had to calculate that distance, which is x. And then later on it says Tana reels in some of the cables, so it's shorter. But even though the length of the cable is shorter, the center of mass will still be at the same point, and that's why I've drawn this line through, so that doesn't shift. Okay, so then we've got to find out that x, and that's this question. And so because why does it not shift? Because it's a closed system, and the velocity of the center of mass will also stay the same. Okay, and then here's another question, and I've written a little bit of the question, and this is how you solve it. And there's 4 questions here, and then there's one here. So each square is 10 meters. So these are A and B have the same mass, and they're approaching each other with different speeds. So we're trying to find, and when you work out, because they've got the same mass, their center of mass will always be halfway between them. And so when you kind of plot the points every second, you find that the center of mass is actually shifting by half a square, which is 5 meters. So every second the center of mass shifts by 5 meters. So this velocity of the center of mass is 5 meters per second.